Universities are important in achieving a sustainable future, especially through research. Dr. Chris Rouse is leading research at the University of New Brunswick to unlock wireless charging for electric vehicles in motion. Imagine driving down the highway and your EV is being wirelessly charged at the exact same time. Here to explain the technology and its potential, here's Dr. Chris Rouse. Hi, Chris. Welcome to Reimagined Energy.
Hello, thank you for having me.
Well, we were talking earlier, and you're doing some really great things at UNB. And tell us a little bit about your research and what led you to where you are now.
Sure. My research mainly focuses on making wireless electrified roadways a reality. So the idea being the roadway in the province, for example, highways or sections of city roads could be retrofitted with basically wireless charging. Wireless chargers, I guess, is the best way to put it. The idea being you drive over that and power is transferred through the road to your vehicle, and at the very least reduces the amount of energy that your vehicle needs to consume to move. And best case scenario, it's topping up your battery as you're driving. And I guess a little background for myself. So I'm from this region. I was the East Coast, I guess, born in Halifax and raised in Fredericton. I did all my education at the University of New Brunswick. Around 2014, I received my PhD. Went out and did an industrial postdoc with a small company in Newfoundland for 2 years. And then I was lucky enough to join Solus Power, which is a Newfoundland tech company that develops capacitive wireless power transfer technology. And I just found that incredibly interesting and really enjoyed. I was there for about 4 years. Really enjoyed my time working with them. But as I got older and got married, wanted to get a house, settle down. I wanted
that happens.
Yeah, I wanted a little bit more of a stable job. The small companies are fun and exciting, but I'm a little bit conservative when it comes to risk and investing in property and everything. So I joined the federal government briefly for 1 year. That wasn't the plan, but that's how it happened. I joined ISED, Innovation, Science, and Economic Development Canada. And my work there was on radio frequency exposure and compliance of primarily wireless power implementations. So I'm still working in this wireless power area, but more on the regulatory side. How do we make sure the technology is deployed in a safe and responsible manner?
Mm-hmm.
But about a year in, I got the offer to come join UNB as a faculty member, and I loved my work at ISED. It was just too good of an opportunity to pass up. So been with UNB since 2021, and I'm kind of combining those past experiences on the regulatory side and then the tech company side to develop these electrified roadways at a more of an academic research and demonstrator level, focusing primarily on this capacitive power transfer implementation. Well,
speaking about that, the wireless transfer, how does this technology work? I have an EV, and my ears perked up as soon as I heard that, the wireless charging bit. So how does it all work?
Sure. Well, I'll do a little step back and just talk about electric roads in general, because wireless is only one solution that's being looked at right now. So the whole idea with electrified road is of course power is transferred to your vehicle while you're on the road. And there are kind of three solutions. Probably the most established solution are overhead lines. So sometimes you see in cities there are bus routes where there are, say, 2 overhead lines, and the bus is kind of grabbing those lines as it's going along, and power is being transferred to the primarily electric bus through those overhead lines.
Yeah, right.
And that's probably the most established implementation, but it's pretty limited. It's not very flexible.
Mm-hmm.
So maybe we could do heavy-duty vehicles like transport trucks and buses that way, but passenger vehicles or vehicles with dramatically different heights would struggle. The other contact-based solution is ground rails. So basically, in the roadway, instead of those two overhead lines, you
Right.
just embed the lines in the roadway, and your car, a little, I guess, contact flap goes down and physically touches those rails as you're driving, and you charge up that way. So those are both a little bit more established,
Hmm.
but of course, the fact that you have that physical connection creates maybe additional points of failure, and is a little bit more. At least electrical engineers, we always like to avoid any kind of mechanical wear and tear as much as
Yeah,
possible.
a little, yeah, more cumbersome. Hmm.
Right. So the wireless power transfer side is basically there's no physical contact between the two.
Right.
So we have these two circuits: the circuit that's in the road and the circuit that's in your vehicle, and they're coupled through either electric or magnetic fields.
Hmm. That is
By
so
far
cool.
the most mature implementation right now is using magnetic fields, so what we call inductive power transfer. And it works very much like the transformers that you see for power distribution. I know not everyone knows how those work, but you might see the cans on your power lines every once in a while. They blow up in a very exciting manner.
Right,
Um,
right.
and these are basically just coils of wire that are very tightly coupled. So two circuits that are physically separate, but the magnetic fields pass through both coils and couple them together, and it's very useful for power distribution for a variety of reasons.
So
Um,
that's how people would fully charge their cars as they're driving along through these coils, wireless coil.
right. So
Why
the
a
idea
coil?
here is they're much less coupled.
Yeah.
There's a big air gap between them, so we have to do all kinds of things to. It's not a new idea at all. This is like Nikola Tesla turn of the 20th century kind of idea. But the technology to do the power transfer efficiently over that big air gap just hasn't been there until
Hmm.
recently. So we work at higher frequencies, and everything's tuned up really, really carefully to maximize efficiency, so we can get that power transferred. And yeah, the idea is you're driving along. There's a coil in the road that gets energized, and it excites the coil in your car. Electricity flows through that coil, and then you just convert it to whatever voltage and current levels are needed to top up your battery.
Well, we're having this conversation, kind of dead winter, spring is coming up.
Right.
And of course, a lot of roads are snow covered. And I know that I guess this type of technology has been around in Europe for some years. I don't know
Right.
how long exactly, but so they have winters as well. So
Mhm.
how would this work in Canada?
So it's a good question. So
Yeah.
my research is a little different. It works on what I call resonant capacitive power transfer. So instead of magnetic field coupling, like I just described with
Mhm.
coils, it's electric field coupling with plates and things like that. And in that area, there are a lot of potential advantages to working with electric fields, but a lot of challenges as well. And for that particular question, the impact of the roadway materials and whether or not they're wet, like
Right.
because they're porous, the roadway materials, or if there's like a sheet of ice or snow, that's still an open topic in my particular research area. So we're actually just delving into that now. We're going to present our first little contribution in that area to a conference in July. But on the inductive charging side, it's a little more established. This is from a white paper that was published recently, but they're claiming that the technology is not significantly affected by snow, ice,
Great.
or precipitation, or the removal of these things
Hmm.
during the length of the project. I'm guessing they're mostly referring to it still functioned. I don't know about the performance.
The strength and stuff like that might be
Yeah,
reduced, maybe?
exactly.
Yeah.
Typically, any kind of water
Right.
is not always electricity's friend. Um,
Right.
the nice thing is, it's not. There's no contact, so the chance of a short or something is not there. But we might see a little bit of more loss in whatever materials are between two coils, or
Hmm.
in my case, between the two sets of plates. Yeah.
Well, how long would somebody need to drive? I know this is all being tested out. I mean, of course, in a perfect world, you would want to go from 10% battery to fully charged,
Right.
but it probably in reality, you probably be a stretch of highway like for 1 kilometer to get you 50%, let's say. Like, what's the
It I think to some degree we're limited by we don't want to hurt the battery. So
Yes.
there are a lot of elements to this. Like I don't think, like, even the vehicle manufacturers strongly recommend you use kind of a level 2 home charger
Yeah.
generally.
Hmm.
The fast DC chargers that you see at gas stations and whatnot are there for those longer trips, but it is a little more wear on the battery. Everything's going to get hotter. They're
Hmm.
transferring quite some power, over 10 times what your home charger
Hmm.
is doing. And I think one thing to keep in mind with the electric roads is the idea is not necessarily to replace your at-home charging. So I think the idea is really that, at where you're starting from and your destination, you're going to do your level 2 charge. So you're going to start more or less with a full battery, and you're going to be able to top up the battery wherever you arrive.
Right.
I don't think that will ever, as long as electric vehicles are around, I think that's always going to be part
It's
of the
standard. Yeah.
workflow.
Hmm.
But the idea here is to, at the very least, for whatever section of electrified road, let's say a car, electric vehicle probably consumes maybe tens of kilowatts while it's driving on the highway. So if we can transfer tens of kilowatts through the road, then you get whatever the length of that electrified section. That's how much you've just increased your driving range. So if the whole way was electrified, you'd start at 100 and end at 100.
Yeah.
Um,
Yeah.
but I think what's more likely is something approaching that fast charging level. So maybe a factor of 10. So say hundreds of kilowatts are being transferred through the road to the vehicle, and then maybe just about a tenth of the entire roadway is electrified. So if you're going along, your battery's coming down, and then it gradually goes back up while you're on the electrified section, and then back down, kind of like a sawtooth.
Yeah.
And then the idea being you would, maybe arrive at your destination with maybe something close to 20%, something where, okay, I'm here now. It's time
Yeah.
to plug in, do the overnight charge. I think that's the goal. With the conductive solutions, it's relatively easy to get those high power levels, but where the wireless technologies are still developing, it's relatively, the tens of kilowatts are comfortable. Getting to the hundreds is still a bit of work. So yeah, it's an active area of research.
Because electricity costs money and
Right.
you're driving along, what would the payment system look like, or how do they do it in Europe, let's say? we're
Well,
in,
yeah, I'm not even totally sure that is completely worked out. I think
yeah.
a lot of what's happened in Europe has been demo projects, right? So it hasn't been deployed as, a national solution to roadway electrification. So I don't think they've quite tackled those questions fully yet, or if they have, they've come up with internal solutions for just this one stretch of roadway. But there are standards being worked on right now with the ISO, International Standards Organization, and International Electrotechnical Commission to develop communication standards between charging infrastructure and EVs that are a little more sophisticated. So right now it kind of works. It seems to kind of work. I don't actually own an EV right now, so maybe soon.
That
But
will be probably soon. Yes.
yeah,
Yeah.
but you go up to the charger, you kind of tap your card and
Hmm.
charge. But the idea is to get to a point where it's what's called plug and charge. So you just plug in, and an entire communication protocol is initiated between the vehicle, which already has your kind of credentials and payment information. You already have a contract with either the vehicle manufacturer or a mobility operator,
Right.
and so that's all kind of done. You plug in, and it kind of manages everything automatically.
Hmm.
So they call that plug and charge, and that's something that's coming. They can do a lot of interesting things with that, like maybe some strategic mix of even where the power is coming from. So if there are renewables available, they can manage all of that digitally.
Right.
Bidirectional. So if it's convenient to, this is probably more for when you're at home, but if it's convenient for your vehicle to actually supply power, that's something that it could manage. And one of the last items is wireless charging. So the idea being, if you pull over a charger, your vehicle is going to talk to the charger, and it's all hands-free. And I think that's probably the path forward, especially for electrified roadways where you can't even get out of the, well, ideally you wouldn't have to get out of the vehicle. So you're just going along. You pre-configured everything,
Hmm.
and then the vehicle is just talking to the roadway system. But there are a lot of players, right?
Yeah.
There's a
Of
lot of
moving
connections.
parts, pun intended. Yeah.
Yes, yeah. So it's exciting, but I think it's still, the
Early stage.
research is moving along, but then implementation will always take time, and kind of getting the economics right. I think that's maybe where things are right now, is a real question, like, is this economically feasible? And that's where the RCPT, the capacitive power transfer that I do, has potential to be a little bit more cost effective. So that's one of the kind of benefits of the technology. But yeah, it's it's one of those things. It's exciting research.
It is.
It's hard to say where it will go, but I just think it's such a cool idea that
Oh yeah, I love
I
it.
want to be a part of it.
You're part of the faculty at University of New Brunswick, and
Yes.
at your lab, you will probably engage a lot of your students. So how do you engage your students as part of this project and others?
Yeah. So I guess generally, like, my time is split three ways. Let's say three major categories, and then in between split in multiple. Again, it's an interesting job in that way. You're constantly context switching. But so there's the academic service side, where it's just supporting the department, the university, running the programs that we offer. And then there's teaching, of course. So a substantial amount of my time is spent delivering courses at the undergraduate and graduate level, and then research. And unless you're in a position where you have relief on some of those other items, a lot of the work, the sort of day-to-day work, is done by graduate students. So basically, I tend to recruit through my teaching. That's probably the main way I recruit. So get students straight from our program, maybe bring them on as research assistants for the summer after their third year, say, and then if they're interested, they come on as we call them accelerated master students. So because they've already got some exposure to the material, and we've maybe already identified a thesis topic, they come in and just run with it. As soon as they finish their undergrad, they're started, and finish as quickly as possible, because one thing right now is the job market is really good for engineers, and
Yep.
a lot of baby boomers retiring.
Yeah.
So a lot of our students here are kind of, the question is, why would I do grad school when
Yeah. When the labor
but
market's so hot. Yeah.
exactly. So
Yeah.
we try to make it as kind of painless as possible. They get they learn a ton. Um, I'll go into what they do in a moment, but yeah, the recruiting side for the master's level, I usually try to do this kind of accelerated path with students that are from UNB. But the PhD side, it's usually, well, because it's a longer commitment, usually it's about 3 to 5 years.
Hmm.
So you need a longer funding runway and all of that. So usually that's a larger, I'm recruiting from outside, and there's usually a company collaboration there to help fund it. In this case, Solus Power is funding helping collaborate with me in funding one of my current students that I brought in from outside. But basically, I usually, all the students lead their individual project, so little portions of moving this technology forward, and I kind of sit at the middle. I help identify the topics and guide them along.
Hmm.
But they really, part of the training is for them to get experience with, surveying the literature, doing any analytical or simulation work, so they get experience with the tools that go along with that. And then a lot of the time they have to design some kind of circuit board, and so they do that part and they learn how to do that. And I'm just there helping them along, because I certainly don't know everything, but I have a fair amount of experience, so I can help sidestep any big problems. But yeah, they build the boards, they do the testing. I'm helping them along the way, but it's really they're driving their own little piece of the big puzzle.
Wow.
And they get to present at a conference. I try to make sure all my students get to go to a conference and present their work and publish, first author and everything. So yeah, I try to give them as much experience as I can in that little period of time.
Yeah.
And then they're gone, and then I'm like, oh no, I gotta find more
square one
students.
again. So
Yeah.
what's next? What's next for you, and maybe even the technology?
Right. Yeah. I think at a high level, it's how can that economic case be made? I think,
Right.
at the really high level, for me specifically, there are a number of items, like, for instance, the impact of the roadway and the weather on our particular type of our flavor
Mhm.
of wireless power is something that's front of mind for me right now. That, and there's the item of misalignment. So one thing I haven't talked about, but the entire lane isn't electrified. Usually it's a segment along, say, about the middle of the lane.
Mhm.
The receiver is usually between your tires, kind of central in the vehicle. But of course, the car can move within the lane. The lanes are wider than the vehicles, and you kind of, there's a bit of natural drift as you're driving. And one of the main sources of efficiency loss in wireless power is when they're not perfectly aligned. So that coupling drops and the performance drops. And this is even more so the case, I'd say, for capacitive power transfer. But we've come up with some interesting solutions to account for that. And there's even opportunities maybe to dynamically correct boards. So with some assisted or autonomous steering, kind of guide the vehicle along so you get maximum power transfer. So that's something that I'm really excited about and in the middle of developing. And compliance. So where especially the capacitive power transfer side has to work at much higher switching frequencies. There's a lot of work to do to make sure that it's not spilling out electromagnetic interference that could cause, say, even systems on the car not to function properly, or nearby electronic systems not to function properly. So a lot of my work is to kind of balance getting the power capacity up where it needs to be, keeping things efficient, but also really making it clean from a emission standpoint, RF emissions. And so with my experience with ISED and the regulatory side, and then working with Solus Power, I'm trying to pull those together to kind of make sure that it's safe from a RF exposure standpoint, because of course human exposure to these fields has certain adverse health effects that need to be protected against.
Right.
And then making sure that it's not going to, so it's making sure it doesn't harm humans, and making sure it won't harm other RF or electronic devices.
Yeah, electromagnetic for sure.
And so that's an area that hasn't been quite explored as much. So I'm bringing my regulatory experience to bear there. And then last is just more power, getting up to the tens and then hundreds of kilowatts. There are other labs that are a little further ahead on that, and I've kind of decided, I don't really, that's not where my expertise is.
You're gonna stay in your lane.
Yeah. Oh, yeah. That's I can see why you got into this. Yeah. Yeah, exactly. I think collaboration could be a way. So if they're making great strides on the power, and I'm making strides on things like misalignment and compliance and things like that, and then together we could have a nice system. So yeah, lots to do. I mean, there are a lot of challenges. It's complicated technology, but that also makes it fun.
It does. And, and it really is something that has great potential, of succeeding. I mean, everything's moving to wireless, and why not cars? Why not the, trucks and so on? But
Yes.
I really appreciate you joining me today, Chris. And it's exciting to learn what you're working on there at UNB. And yeah, I mean, we'll have to come back in the future just to do a quick check-in to see, in a few
Absolutely.
years when we're all
Yes.
electric. Yeah.
Oh yeah, even human beings will be just robots at that
We
point.
will be.
Chips in our brains and everything. Yeah, thank you so much for having me. It was a pleasure, and yeah, hopefully in a few years have some more exciting things to discuss. That'd be great.
Wow. Pretty cool, eh? Now that's reimagining energy right there. This podcast is supported by the province of Nova Scotia and the Smart Energy event. I'm your host, Maria McGowan. Thanks so much for listening in and hope to see you next time.